Welcome to Geometry PLP Essential Standard 1 Learning Target 2B. Today we're going to talk about midpoint and distance formulas. So first of all, we're going to talk about some definitions. Midpoint, so if you read there in the red, the midpoint is that divides a segment into two congruent segments. If you remember some keywords in here, congruent. Congruent means equal distance, equal size, same distance, same size, and we divide something into two equal parts. Think about the middle of something. The middle is going to divide it into two equal pieces, so that's what a midpoint is. It divides a segment into two congruent pieces, which by definition of congruence will make them equal. Segment bisector, a point, ray, line, segment, or plane that intersects the segment at its midpoint. Segment bisect, if you bisect something, it means to cut it into two equal parts. So if you bisect something, it cuts it at the midpoint because the midpoint is what cuts something into two equal parts. So first example that we're going to do is we're going to use those definitions and we're going to find RS. So if you look at this diagram over here on the right hand side, RS is this entire length right here. So RS is the entire length. Notice we have this little mark right here and this little mark right here. If you remember, those marks mean congruence. So this section RT and this section TS or segment is going to be the exact same thing. So what you're going to do is you're going to take and you're going to add 21.7 and you're going to add 21.7 because these two segments are congruent. So you add those up and you're going to get 21.7 plus 21.7. 21.7 and 21.7 is going to be 43.4. If you do the next one, find AB. Again, notice the marks right here. AB. So that means that AC is congruent to CB because these mean congruence. So you're going to take 2 1/4 and you're going to add it to 2 1/4. 2 1/4 plus 2 1/4 is going to be 4 1/2. And that would be your segment. All right. If we look at this, it says D is the midpoint. Notice this definition of midpoint. D means it's the middle of line segment EF. ED is 4x plus 6, so there's 4x plus 6. And DF is 7x minus 9. There's DF, 7x minus 9. It says find ED, DF, and EF. So what do we know about this? We know that D is the midpoint because it tells me that, which means that it's directly in the middle. And since it's directly in the middle, it's going to make this segment ED and this segment DF the exact same thing. So how do we set this up algebraically? We know that 4x plus 6 and 7x minus 9 are congruent, which means that they are equal. Since they're equal, you make them equal to each other. Solve the equation using algebra skills from Algebra 1. You have an x on the left side and the right side. You need to get your x's together, so you subtract 7x from both sides because you want 7x to go away, so you use the opposite of 7x, which is negative 7x. So then when you subtract that, you get negative 3x plus 6 equals 9. You then subtract 6, and you get negative 3x equals 3. You divide by negative 3, and you get x equals negative 1. But in geometry, you have to really ask yourself, what does the question want me to find? The question says find ED. So since we know that x equals negative 1, how do we find ED? ED says to take 4x plus 6, but what do we know x is? X is really negative 1 plus 6. We then multiply 4 times negative 1, which is negative 4, plus 6. Negative 4 plus 6 is 2. So ED is really 2. Well, what else do we know? We also know that DF, excuse me, that's supposed to be an F there, not an E. So DF should be the exact same thing. Why? Because the definition of midpoint says they're equal. So DF is equal to 2. And it also says to find EF. Well, what do we know about EF? EF is the entire length. Well, if ED is 2 and DF is 2, then when you add those two together, you're going to get 4. Okay? So there's also another thing called the midpoint formula. The midpoint formula is used when you're given ordered pairs and you don't want to necessarily graph and then find the middle of things. Okay, so the midpoint formula M of line segment AB with endpoints A, x1, y1. So this little subscript, that's a subscript. It just means the first x value and the first y value. And B, x2, subscripts are lower, means the second x value and the second y value. So we have the formula x1 plus x2 over 2, y1 plus y2 over 2. That's the midpoint formula. All the midpoint is the middle, or another word for middle mathematically is average. How do you find the average of two things? You add them together and divide by how many there are. If there's two of them, you add two things together, divide by 2. You add two things together, divide by 2. So that's the midpoint formula. So let's actually use the midpoint formula. So here's a diagram. They give us ordered pairs. E is -2, 3. F is 5, -3. Sometimes it's easier if you can see what you're doing. So we graph the ordered pairs -2, 3. We graph the ordered pair 5, -3, and we draw it. So the midpoint is going to be right in the middle, somewhere in this range right there where I drew the blue point. I don't know exactly what that is. So we're going to find the midpoint. So I put this blue point on here just to kind of give me an idea. So when I get done using midpoint formula, this blue point should be or really close to the midpoint that the formula gives me. So what you do is you take your first x value. So I take my first x value, -2, and I add my second x value, which would be 5, and I divide that by 2. And this is an ordered pair. This is a point. So I put it in ordered pair form. Parentheses, -2 plus 5 divided by 2. I take my first y value, which is 3. I add my second y value, which is -3, and I divide that by 2. And I'm going to put that in ordered pair form. Notice up here it's an ordered pair. It's an x value and a y value. So -2 plus 5. -2 plus 5 is 3. 3 divided by 2. 3 plus -3 would be 0 divided by 2. 3 over 2 is a fraction that can't reduce. Whenever we're looking at fractions graphically, sometimes it's easier to look at a decimal. 3 divided by 2 is 1.5, comma, 0 divided by 2 is 0. This right here is my midpoint. Now what we do is we use our diagram. If I look over here, 1.50, that ordered pair, 1.5 to the right, up and down 0. So does this ordered pair and the point that I put on my graph, are they in the same locations? Yes, they are. We double check. That's where our graph is. That's where our point is. We're good to go. So let's look at another one. It says the midpoint. M is the midpoint of xy. X has the coordinate of 2, 7. M has the coordinate of 6, 1. Find the coordinates of y. So what we're trying to do here is we're trying to find the endpoint given a midpoint. So again, graph it. 2, 7, right 2, up 7. I believe that's 2, 7. 1, 2, 3, 4, 5, 6. I need to go one higher. So let me erase that point there. Okay, 2, 7. My midpoint is 6, 1, so I go to the right 6, 1, 2, 3, 4, 5, 6, up 1. This is the middle. So if I look at that, this is one endpoint, x. This is the other, or this is the midpoint, m. So my other endpoint would be somewhere down in this region here. And again, this is just an estimate. It's not perfect. We're just kind of showing when I get done, my ordered pair should be like 10, -7 or 10, -6. Let's give it a shot. So what we do is, this one's a little different. We have our midpoint formula, which says 2 plus the other endpoint, but I don't know the other endpoint. we'll call it x over 2, comma. Our first y value, which we don't know, or excuse me, we do know, is 7. Duh. Is 7 plus y over 2. The problem is we don't know what x is, we don't know what y is. But we do know the midpoint. The midpoint is 6, 1. Okay, so what we do is we use algebra. This is the x value. This is the x value. So we do 2 plus x over 2 equals 6. Solve that equation algebraically. We have division, so I want to get rid of division by multiplying. So I multiply by 2. And we get 2 plus x equals 12. We solve that equation by subtracting 2. And we get x equals positive 10. Okay? Does positive 10 seem like it would work over here? Yep, and we even mentioned that a minute ago. 10 is what we thought. Now what we do is we look at the green. This is the y value. This is the y value of our midpoint. 7 plus y over 2 equals 1. Multiply both sides by 2. So we get 7 plus y equals 2. Subtract 7 over, and I get y equals negative 5. Now, earlier I said negative 7. Negative 5 seems perfect. So my ordered pair would be, when I wrote 7, negative 5. That is the other endpoint, y of my line. Okay? What some students do, sometimes people get bogged down with this formula. What you can do is graph it and then count. How did I get from x to my midpoint? I went down 1, down 2, down 3, down 4, down 5, down 6, right 1, right 2, right 3, right 4. So then you could go down 1, down 2, down 3, down 4, down 5, down 6, right 1, right 2, right 3, right 4, and there's my point. This is the exact location. Now you just have to figure out what that ordered pair is. So there's another way to do it. So now you guys pause the video and try this one on your own. When you pause the video and you did it on your own, you should get something that looks like this. It says S is the midpoint of RT, R has a coordinate of negative 6, 1, and S has a coordinate of negative 1, 1. Find the coordinates of T. So again, what I like to do is graph it. And this doesn't have to be perfect. So R is negative 6, negative 1, somewhere in here. S is negative 1, positive 1, which would be right here. Now this is R, this is S. S is the midpoint. So that means that my point that I'm going to be looking for is going to be somewhere over in here. This would be T. So then what you can do is, how do you get this point here? Use the formula. Okay? Negative 6 plus x over 2, comma, negative 1 plus y over 2. And that's going to be equal to the midpoint they give me, which is negative 1, comma 1. So what I'm going to do in blue is I'm going to do the x's first. Negative 6 plus x over 2 equals negative 1. Multiply both sides by 2. You're going to get negative 6 plus x equals 2. I multiply both sides by 2 to get rid of the division. Those reduce out. Add the 6 over, and I'm going to get x equals 8. Okay, now I'm going to do the y, and I'm going to do it in red. So I'm going to underline it in red so you understand that. Negative 1 plus y over 2 equals 1. Multiply both sides by 2 to get rid of division. These reduce out. Negative 1 plus y equals 2. Negative 1, I need to add that over, so I get y equals 3. So does the ordered pair for T of 8, 3 seem like it could be right? I go to the right, 8, up 3. That's in the right location. Again, this is not a perfect graph. It's not drawn to scale. I don't have coordinate plane. I don't have grids on there, but it gives me an idea. 8, 3 could be right. Okay, radicals. We're going to look at the distance formula here in a minute, and what's going to require us to look at radicals. So we need to simplify radicals. The square root of 100. So the square root of 100, hopefully you guys realize that that's 10. Okay, but what we're going to do is we're going to look at how to simplify if it isn't a perfect square. So what you can do is, what I'd like to do is take this and break it apart. A square root is looking for two numbers that are the exact same. So what I do is I think about 100. How can I split 100 up? 10 times 10. Once these are paired up, circle them. One escapes, goes outside of the radical. The other one gets crossed off. So this just becomes the number 10 because we're looking for two numbers that are the exact same. 64 is really 8. Again, you can break that up as 8 times 8. These are paired up. One of them comes out of the radical. The other one gets crossed off because we're looking for two numbers that are the exact same. What are some other perfect squares? Well, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. So on and so forth. They go on forever. So there's an infinite amount of perfect squares. All right. So what perfect squares surround these numbers? So like the square root of 64. Well, the square root of 64, the square root of 64 is really close to the square root of 64. The square root of 64 is 8. So this number right here is going to be a little less than 8. So if this is 8 on a number line, here's 7 on a number line, here's 9 on a number line, square root of 8 would be right here. Square root of 6, or square root of 60 is going to be just smaller than that. Why? Because the square root of 49 is 7. So we can compare the square root of 96. Well, if we think about that, what's it close to? It's close to the square root of 10, which is, or the square root of 100, which is 10. So there's 10. Square root of 96 is going to be right below that, and you can use a calculator to approximate that. Okay. Find the distance around the triangle. So distance means how far. So what is the distance around this triangle from A to B to C back to A? So count the distance. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, and 4. But what about this diagonal right here? Okay. So we have to figure out this diagonal right here. Well, one of the things that we're going to talk about is how to find the distance of this right here. You probably remember from earlier math classes the Pythagorean theorem. You take a squared plus b squared equals c squared. A squared is 8 squared plus 4 squared equals c squared. 8 squared is 64 plus 4 squared is 16 equals c squared, which is, we don't know. C is this one right here. A and B are the two shorter sides, so you do 64 plus 16, which is 80, equals c squared. And then what you do, we don't want c squared, we just want c. This is just c right here, not c squared. So c is the square root of 80. Okay, and you can approximate that. Use the calculator. Square root of 80. So you can get your calculator out. So the square root of 80. So here's my TI-84 calculator. So square root of 80. Hit enter, and you get 8.99. So C would be 8.9 approximately. It's not perfect, but it's pretty close. Okay. So the distance formula, it says in a coordinate plane, the distance is between 2 points is you take x and y, and you take x and y, and you plug them into this formula. Distance is always subtraction, x squared minus, or x2 minus x1 squared plus y2 minus y1 squared. The distance formula is just an extension of the Pythagorean theorem. What we're going to do is we're going to use the Pythagorean theorem. Notice we find the distance of our x's, we find the distances of our y's, and we square those. Okay? And then we add them together and we take the square root. We did that on the previous question. So here's what you do with the distance formula. We take our x values. So here's our first ordered pair. Here's our second ordered pair. We plug them into the distance formula. D equals the square root of x2. x2 is negative 4 plus, minus x1, which is 3, and we square that. plus. We take our y2, 3, minus our y1, which is 2, and we square that. Essentially what you're doing is, if you wanted to, you could take this and draw this down and draw this over, and guess what? This is a right triangle. The distance to go down is 1. The distance to go across is 7. And that's what this formula is going to give me. It's going to give me the distance across here from left to right, which is 7. And then I'm going to square that number. Now, this is negative 7, but whether it's negative or positive, negative just means if you're going to the left or down. Positive means you're going to the right or up. So negative 7 squared, 3 minus 2 is 1 squared. So basically, to get from R to T, we went to the left 7 and we went up 1. Left 7, up 1. We then square those numbers. Negative 7 squared is positive 49 plus 1. 49 plus 1 is 50 equals D. And then we use the calculator and we would get set a little bit bigger than 7. It's going to be like 7.1-ish, somewhere in that range. Okay? It says determine if FG and JK are congruent. Basically, that means I need to figure out, are these distances the exact same? So how do we go about doing that? We use the distance formula. This ordered pair right here is 1, 2, 3, 4. This ordered pair right here is negative 4, 0. This ordered pair right here is negative 1, 1, 2, 3. Negative 3. Write that a little clearer here. Negative 1, negative 3. Okay? This ordered pair here is 1, comma 2. And this ordered pair here is 5, comma 5. So then we just use the distance formula. Find FG. So the distance of FG is, we take FG, which is 1, 2. So we take 1 minus 5. And it doesn't really matter which one you call 1 and 2. I can call this one 1, call this one 2, as long as you're consistent. Plus, so notice I use this one as my in the first. So I use 2 minus 5. And then I square that. So I simplify that, and I'm going to get negative 4 squared plus negative 3 squared. And when I do that, I get 16 plus 9. And the square root of 16 plus 9 is 25, which becomes 5. Then I'm going to do the same thing for JK. So here's JK. So JK is going to be equal to, take my first x value, negative 4, subtract my second x value, which is negative 1. So notice it's a double negative. The formula has a negative, the x value has a negative, and then I square it, plus I have 0 minus negative 3. Again, notice the double negative. I then square that. The double negative really becomes a positive. So this becomes negative 4 plus 1, which is negative 3, squared, plus 0, double negative is a positive, so 0 plus 3 is 3. So this becomes 9 plus 9, which is the square root of 18. The square root of 18 is a little bit bigger than 4, so we'll call it 4.1. I don't have the calculator pulled up. We'll say it's about 4.1 if you want. You can pull the calculator up and do that. The big thing is, are they going to be congruent? No. One of them is 5, the other one's 4.1. They are not congruent. That concludes our lesson for today. So sign up for your teacher talk, and